Hello, this is Panda Consulting's ArcGIS workshops, and today we have something a little special for you. Before we start, um, you'll see a QR code up on the screen. That is a QR code to Panda Consulting's website. You can find out who we are, what we do, how we do it, anything else you want to know about us. In the meantime, let's go ahead and introduce Jason Cox. Jason is the Application System Analyst 2 at Tallahassee-Leon County GIS. And Jason recently gave this presentation at the 2023 ESRI User Conference, and it was so impressive that I asked him to come and do it again and share with everybody, and especially those people that weren't there. So Jason, go ahead and share your screen, and you can take over for a while.
That's good. Apologies, wrong screen.
Yeah, there you go.
Good afternoon. Thanks for joining me today. I'm excited to share with everyone in my dive into the deep learning tools available through ESRI's Image Analyst extension and ArcGIS Pro. My goal is to kind of make sure that you all kind of see the benefits of deep learning tools in ArcGIS Pro, what it can bring to kind of GIS field, and how powerful the tools are without the need for really any coding or any kind of math on the user's end. So without further ado, we'll get started. So the major task that we have in the field of GIS, at least for me, is to detect objects in imagery, right? To create data. So given a set of imagery, I want to find a way to extract information without the need for spending manual labor, hours and hours of manual labor. So, for example, part of my job entails capturing change in the residential structures throughout Leon County for non-ad valorem fee assessments. So for the purposes of getting fees for solid waste collection, stormwater fees, etc., fire service fees. So having a good account of the residential structures on any given parcel is tantamount to that. Given a set of imagery, I would love for a way to capture change. So I figured, why not delve into the world of computer vision for that task? So I did some research a few years back and realized that ESRI was starting to dip their toes into that world. So I thought that would be a good use case for kind of stepping into the world of image analysts and to seeing what it can do for me. So image analysts use deep learning, and deep learning uses artificial neural networks, and it's just essentially an architecture for taking data input, utilizing mathematical algorithms. So as simple as creating these algorithms using NumPy, but I wouldn't recommend building these using NumPy or even going into the raw TensorFlow or PyTorch and generating these layers. Because these layers, if you're using the Image Analyst extension, are already kind of built out for you in the models that are available. So really all we need is we need an input and we need an output. And we can define the different parameters that we set for those hidden layers within the tools themselves. So really it is like a plug and play. To get started, you do need a license to the Image Analyst extension, or you can request a free, I think it's a month, I believe, available license to you to kind of play around with the data, which I did. So what is useful to know before you get started is that it does require NVIDIA CUDA compute GPU processing. So that's the one thing that you'll need to make sure that your computer has is that it has an NVIDIA GPU. And once you realize that that's what you have on your computer, you're set to go. Pretty much there's a few specifics as far as what's recommended as far as the amount of RAM and then your minimum CUDA compute capability, but most modern cards have that. And ESRI does recommend 8 gigabytes of RAM, but if you're going to do any data training on your own, I do recommend bumping that up at least to, I believe if you're using Pro, I would say go with 32 gigabytes of RAM, but you could probably get away with 16.
So Jason,
yeah.
I have a question for you.
Mm-hmm.
Can you describe for us what your computing system looks like? I mean, what have you got on the one you use?
I have 64 gigabytes of RAM, and I have a NVIDIA A4000 card, which is a 16 gigabyte card. So it's definitely not, it's a decent card. It's definitely not top of the line, but it is a pretty decent workstation. I believe probably about the $2,000 range if you were to kind of purchase.
And it's solid state drives, or do you have spinning drives?
Correct. Yep.
Solid state. Okay.
So the solid state doesn't matter as much as the GPU as far as processing the tensors that you need to feed into the deep learning architecture. So by far, the amount of RAM and the GPU are important. However, if you are working with a lot of data, storing a lot of image samples, then yeah, you do want a solid state drive so we can access those in a quick manner.
Okay, interesting. Thank you.
Mm-hmm. So one task that I had, and it's something that we've been wanting at Leon County for quite a while, are service roads for interior kind of shopping complexes. So for Leon County, we do maintain a street center line data set. We aren't the authority, but we do map it for our partners at growth management for both the county and the city. And we do display street center lines on base maps. However, we don't have kind of those interior parking lanes that would be useful for emergency response or just for showing within base maps. So as we see on our popular kind of mapping application with Google Maps, it's kind of something that is kind of drawn in that brings context to maps where you see those kind of interior lanes. So I would love a way to kind of automate that process of not having to go and manually digitize all those lanes, because that would take, months to do for, the shop of our size. And I didn't really want to spend the resources doing that. So the question was, can I scale that using deep learning and image analyst? So throughout my research and kind of digging into the ArcGIS API for Python, I learned that there is a model available to us to use within the ArcPro environment, and that is the automatic road extraction using deep learning. There's a multitask road extractor model. So that model has already been built out as far as all the layers, all the in the neural network that we saw earlier. All I need is to feed it sample input to generate my output. And so that's what I'm going to go through next. Okay. So the first step is utilizing the export training data. So we need to create training data for the model to learn. And the goal is to kind of feed in the data so that the model can learn what a parking lane is and what it is not. So what I need to do is generate a few different areas of samples to create a good set of data to train on. So here we see in these kind of bounding boxes areas where I have manually digitized these parking lot lanes that I want to capture. So when I feed in the model, I will utilize these specific areas and this specific data set. So the polyline data for the parking lot lanes, and then the bounding boxes for my kind of area of interest. So looking at that tool, what we see is we have our input raster, which is going to be our imagery, output folder for training data, our input feature class, which is those parking lot lanes that you saw I had drawn, buffer radius of 10, because we are actually feeding the data in as pixel raster data and not polyline data. So I buffer those center lines with a radius of 10. Input mask polygons is my training area. My image format I kept as TIFF, so I have a better resolution. And I kept a smaller tile size as 256 by 256. You can bump that up, say like 512 by 512 to create larger image chips. It'll just take a little bit longer for the model to go through and kind of train on each of those chips. Now the stride, it's essentially the overlap between the training data. You don't have to have any stride. However, if you don't have a lot of sample data, the stride is useful for creating more samples out of overlapping areas. So in this case, I went ahead and gave it a stride of 128. All right, so what I did is I kept my reference system as the map space, and I processed them as a mosaic image. In my output metadata format as classified tiles. And the great thing is when you're first starting to utilize these tools, you might not be sure of kind of what metadata format you need to use, but the descriptions within the help are very useful to go through and figure out, okay, what metadata output do I need for the specific task at hand? So in this case, I want classified tiles because I'm looking at image chips and I'm trying to use the multitask road extractor model. That's all spelled out in the help documentation and the sample notebooks and the ArcGIS API for Python, which I'll show you at the end of the presentation here. Okay. And the next step is training that model. So what I need to do first is the output of that geoprocessing tool where I exported the data is going to be the input of this tool where I train the deep learning model. And I'm setting my model type as multitask road extractor, which is pixel classification. And as we see in the model arguments, you can set your chip size to the size that you had in your training data. I left everything else in this case as the default as far as the Gaussian threshold and the bin size and the theta. You can go in and fine tune those model arguments and the parameters. However, if you're just kind of running a test, it's best to kind of just keep the default and kind of look at a smaller area and kind of fine tune as you go along. And that is kind of one of the benefits of kind of running these through Image Analyst. A lot of the hard things are already set for you as kind of pre-populated values. So under advanced, if we go look at learning rate, you don't have to enter anything into the learning rate. You don't have to set anything. It'll automatically calculate this tool, the best learning rate to implement on your model. And that is also available as stopping the model when it stops improving. So if I set the model to go, say train for 50 iterations or epochs, if it stops learning after epoch 25, it's not going to continue and waste all that time training if it hasn't stopped improving. So that's really the benefit of using these tools is a lot of the kind of hard work of kind of fine tuning the model has been done for you within this trained deep learning model geoprocessing tool.
I can tell you, Jason, that I mean, I'm old school. I remember when we used to do this sort of image analysis, in which we dealt with supervised and unsupervised classifications and looking through the spectral space. And the advantage that this has is that it allows you to go and see if we can learn what all these things really mean. Because when we were doing them old school, we'd have to run it one time, and if it didn't come out the way we thought, we'd have to go and train it again. This process seems to just take all of that iterative component and let it continue to learn until it maximizes the effect on there. That's really
right.
interesting.
That's the benefit of the neural network architecture.
Right. Go ahead. Sorry.
Yeah, that's a great comment. Thank you. So what you want to set in the trained deep learning model geoprocessing tool is the processor type to GPU. So I have 2 GPUs on my machine. What I can do is I can set to GPU 0, which is my one of my GPUs. If I have my second GPU I want to use, I can set it to 1. At this time, you can't utilize both GPUs using these tools. You're only able to use one. So that's just a FYI there. All right. And what you'll get is you'll get a model metrics with your loss graph, and you'll get some performance samples as output from that tool. And the loss graph, what you want to see is what we're seeing here is you want to see the training set and the validation set, which is automatically kind of broken out using that tool. So you don't actually have to say, I want to use this specific area as validation, this specific area as training. It will kind of break that out for you. And it will say that, okay, so far the loss, so which is kind of the indication of how well the model is learning, is decreasing over time at the same rate that kind of validation is decreasing, which means our model is performing pretty well. Now, our training is fitting better than our validation set. We see that line is lower than the validation, which means that the model is learning better on our training set than our validation set. However, these are still pretty close together. So I would say that there's not a whole lot of overfitting to the training set. And so it's still a pretty good model. So what I want to do now is run that trained model on an area to see how well it does. So in this case, since I'm using the multitask road extractor, which uses pixels, I want to use the classify pixels using deep learning tool. In this case, I'm using my input raster, which is my imagery. I'm setting an output raster. I'm using that model definition, which I created, which is a deep learning package, that suffix.dlpk. And there's also a Esri model definition file that's created, a .emd, that you could also use. All right, and so let's take a look at the results. All right, so as we see here, and kind of the yellowish pixels are the areas that have been identified as roads/surface roads based off of my input data. So it is a pretty good job in these kind of interior parking lanes. And as we see it not doing as well on kind of the roads that we already have kind of center lines for, that's kind of to be assumed because I didn't really feed it any of the areas for like roads that would be classified as like streets that we already have in our data. So that's good. What I would need to do is just do some manual processing on my end to kind of do further cleanup. Or what I could do is I could take the output of the data and feed it into a new model that can learn on top of the data that's been created. But we'll kind of get to that as we kind of go along here. So
just one more question. So if you go back to that last slide.
Yeah.
So it processes the entire image, right? It doesn't process selective.
It processes whatever extent that you want to set up. So you can do it. So if you go into the environment settings, let me go back. So within the environment settings, you can choose to just go in and set whatever extent is in your map pane, and it will grab that extent. Or you can set it by, as you know, in also environments by a surface, like a polygon extent.
All right.
Or you can run it on the entire image. In this case, our entire Leon County. It probably took me about, I'd say, 2 days to run in total. So it is good to, when you're using this, to like test how well the model did on a specific area. Just run it on a small area, okay, to kind of to begin with. And if you kind of get good results from that, I would say go ahead and run a larger area. However, the model doesn't produce results that you're expecting, not good, I would say create more sample area for it to train on. Or you take the bad results that you got from the running the model, create new line data from that, and just kind of feed it into a new model. So that's one of the other benefits of using these tools is that you can use a model that's already out there. Say, if I'm trying to train on buildings for Leon County, I can use ESRI's building model and train on top of that for a local area. So if you use like the results of like your bad model and kind of clean it up a bit, feed it into a new model that you can try to get better results from.
So if you go back to that results image there, so any speculation why you're not necessarily telling it to not look at the actual roads themselves, but and I'm trying to think through this here. Why is it that some of the roads, some of the exterior roads are being identified? Is it because they have fewer lanes and they more match the actual signature?
It could be with the markings, the way the kind of pavement appears within that kind of that radius that I gave it. So as we recall, when I was kind of creating the tool, I gave it a 10 pixel radius. So it could be that it's utilizing the neighborhood, and that's kind of also the benefit of the multitask road extractor is it's not only using like the pixel value, but kind of the way that kind of the pixels connect with each other, like I say, right angles or at like edges. So unfortunately, with like deep learning models, it is kind of information in, information out. There's really no way to go in and to ask it, why did you choose this as an area you've identified as a parking lane and say, not another area? Really, the only thing you can do is feed it in more data to try to get better results.
As I've always said, the software is really stupid. It does
Yeah.
what you tell it to
Yeah.
do, not what you want it to do.
Mhm.
So you actually have to be really careful in how
Yes.
you're
Yes.
defining
Yeah.
you're defining these signatures.
Absolutely. Yeah.
Perfect. Well, go ahead. I'll let you continue.
Sure. All right, so as we see here, we could tell probably in this case, the reason why I didn't classify this area as a parking lane is we see this kind of stop to the right there where it's picking that up is like, that's not a parking lane. I don't recognize this. You didn't feed this to me in my sample data. And that goes right back to your example that you're talking about. All right, so now I have pixels, but I want to create polylines out of that data. I thought I was able, just use raster to polyline, it'd be fine. But turns out it's not so simple. So when I tried running that and trying to run the thin tool on that pixel data, we see that the thin tool doesn't really work well on pixel data. So I'm gonna have to go find a way to create better raster data to then run thin on so I can get those parking lanes. So I ran through a few kind of tools to clean up the data. So the first thing I did was resample. So I changed that 0.5 cell size to 3. So as we see better results down there. It's a little cleaner. And from there, I cleaned up the boundaries a bit to make the boundaries a little smoother for those pixels. And now running thin, as you see on the right-hand side, I get better results for kind of that raster. And so now I can go ahead and run that raster to polyline to create those lanes.
So just to fill everybody in that's not familiar with some of these raster to vector tools, the thin tool basically goes and takes those pixels and all match the same and draws them, basically tries to find the center line of the pixels and create a vector off of that. You'll still see stair stepping, but it goes and sort of compresses the size of those areas and tries to figure out what the center of it is, correct?
Yep, you got it.
Perfect. You got it. Okay, go ahead.
So from there, I can run raster to polyline. And as we see, we got our polyline data. However, it's kind of wavy. It's not how I want to kind of portray these parking lanes. So there's additional work I need to do. So I learned that to clean that up, I can run a generalize and then run a densify, which adds more vertices to the polyline data, and then I can snap the data together. So running generalize, we see that I can kind of smooth out that line work. And then a optional step, as I mentioned earlier, is to densify to add more vertices and try to use the snap to kind of create better results. So in some areas, it does what I want to do. In other areas, it doesn't. It actually breaks some areas. So it's not going to be 100% perfect, but it'll get you about 95% of the way there as far as what you want your polylines to look like. So if we kind of take a look at the results here, on the left-hand side, we have a shopping complex that comprises a home goods and what used to be a Steinmart and like a fresh market. So it's kind of your traditional kind of pocket commercial complex that you would see, which does a pretty good job of picking up those parking lanes. Now on the right, we see some pretty bad results. And this is a parking lot for Doak Campbell Stadium. And what I realized is that the reason why it's not picking up these lanes correctly is because there are actually yellow markings that run parallel to the parking spots that are confusing the model. And it's not picking these up as parking lanes because in the training set, I didn't have these yellow parallel lines running across the parking spaces. So as you mentioned earlier, it is kind of dumb. It's only going to really recognize what you feed it in as sample data as those parking lot lanes. If it finds something doesn't quite fit, unfortunately, you're not going to get the results you're looking for, unless I go back in and create samples for this area and then retrain the model.
Or it could be it's University of Florida Gator fans and not Seminole fans.
That's right. I trained the model to be a Gator fan.
Good, thank you.
Yeah, no problem. And another example here where we have an apartment complex in addition to a health services complex. I believe that's the Veterans Hospital on the left-hand side there, as opposed to our municipal service complex on the right. As we see with the color of the pavement and like the organization of the roads, the model just has a very hard time of picking up any sort of parking lot lanes within that data. So once again, it's a case of, have I gone back and kind of created samples for this area for these kind of more municipal like service kind of complexes, it probably would have performed a bit better. So to kind of wrap up that process, just to clean up the vector data, is just run a resample, a boundary clean, thin, raster to polyline, and then once I have my vector data, just do a generalize, and that gets me about 90% of the way there as far as like the final data that I need as far as getting those service lanes. So all in all, this process, I'd say training the model didn't take, so creating the samples was really easy. That took me about 30 minutes, if that. Training the model didn't take very long. It took about, I'd say about an hour. What's going to be quite time consuming is if you're going to run that on the county, because just the size of the county, that'll take a few days to run. If you're looking at a smaller area, a couple of minutes. But yeah, all in all, from start to end, I would say the deep learning process probably took about 3 days, and then just QA/QC on the data and create some attributes that we needed for the data for our base maps that the model wasn't trained on. It took about a week or two, so a few weeks. So under a month, we got all this created for the entirety of Leon County, whereas if we were kind of go in and try to manually digitize this data, it would take us a few months. So definitely a time savings there.
Yeah, at least a few months, definitely.
Yes. Mm-hmm. So in addition to that, I'm going to go over a few other kind of projects that I've been working on, also using deep learning tools. One of those is kind of colorizing our black and white aerial photographs. And why would you want to do this? Well, I didn't really have a good answer for that other than what I thought it would look pretty cool, because we had a set for each decade of black and white imagery for Leon County that our staff has spent over the years a number of hours kind of creating mosaic out of. As we see in the slide here, that's kind of stitched together imagery, and we have a number of features, say, forested areas, buildings, etc., that are great to look at in black and white. I thought, these models exist out there. There's a CycleGAN and a Pix-to-Pix model that do kind of image translation, and the common sample is, translating horses to zebras and back and forth. So I thought, why not try to train, this black and white horse to be or black and white zebra to be a color horse. So I want to go ahead and see if that were possible using the deep learning tools. So the first thing I wanted to do was make sure that I had the sample data appropriate to do this. So I had color imagery as far as our 2021 3-band RGB. I didn't have really, I thought, anything to train on the black and white, but I realized I could just take a single band of that RGB and create the black and white training data for that. So that's what I did. So that's what we see at the top here. It's just a single band of that RGB imagery. And so here we see kind of the results of that model training, and it actually does show that it is kind of learning how to translate between the black and white and the color imagery. And kind of a quick example of like, the CycleGAN versus Pix-to-Pix results, it does a pretty good job. Now, Pix-to-Pix actually learns on paired imagery, which we do have, because that's what we fed into the samples. However, it is a more conservative model, where CycleGAN works on unpaired imagery, which we don't necessarily need to use because we do have paired imagery. We have a set of black and white for 2021 and color for 2021, but it is less conservative as far as how it trains. So it actually does a better job of creating kind of those deeper colors where it tries to emulate exactly what the 2021 data looks like. And that's what we see on the left here. So as you see, that's 1954 imagery that we got from black and white. And that is pretty impressive. It does a really good job on forested areas, kind of natural areas, less so on kind of like building tops. You do have a lot of, grays and beiges, as you would imagine. But as there's, not a lot of kind of color work with like reds and yellows, etc., you're not going to get really a lot of those in like the building roof lines. So if, you had different color roofs back then, you're really not going to kind of get that out of the data. it's going to be, grabbing a lot of what it sees in the imagery, which are those, earth tones, and, the greens and the browns, etc.
I was just going to ask whether or not there were any seasonal variations in here, and whether you had the metadata about what seasons these images were picked up on.
Yeah, so exactly. That's another thing. Depending on when you train the data, that it'll influence the way the data looks. So for our color imagery, we get those flown in January.
Okay, thank you.
So the kind of big GIS task that a lot of people want to utilize is the extraction of features from imagery. And here we see our 1954 imagery again, where I have set like a little kind of bounding box of an area of interest where I've identified buildings. And I thought, okay, I know an ESRI building model exists, but what if I can train a model using my own sample data to kind of extract buildings from these black and white, historic aerial photographs? And it took about 15 minutes. And as we see, it produces really good results. So from 15 minutes work, I can run that on the entirety of the county, and I can create, a data set of, buildings from, 1954 with kind of minimal QA, QC on the back end from GIS staff or interns, just, verify that everything looks correct. But, as, you could probably attest is that, creating data from scratch and digitizing all these buildings is not necessarily, the most, I guess, enriching project. It's something that might need to be done, but this way it can be done and not kind of constrain resources or staff. Their time is better used elsewhere. Same thing for kind of extracting historic tree cover. Here we see a small sample area where I've designated areas of forested areas, tree cover areas, and creating a result that is pretty good. There's once again some manual cleanup required. Oftentimes it'll select areas over roads like canopy, which, as we know, there's going to be canopy visible over roads, but that doesn't necessarily mean there's forests over those roads. But that's just the nature of trying to identify things through imagery. And then, of course, change detection between imagery. So here we have two sets of imagery on the right here. And you can run a model, a change detection model, to define what kind of areas have changed and kind of extracting that impervious data. So all those are kind of cool GIS tasks that can be done using the image analyst extension. And I have some useful links here. So if you want to kind of dive deeper into the nuts and bolts of deep learning and kind of constructing neural networks from scratch and kind of using NumPy and going into TensorFlow, I would recommend going to Coursera and using their deep learning specialization. However, that's going to really be overkill for a lot of people. If you want to get like the ground running in kind of really user-friendly way, kind of learning these kind of deep learning tools, but outside of the ESRI environment, I'd recommend fast.ai. That's kind of really a useful online course that kind of got me started. And of course, there's always kind of Google Colab, TensorFlow, and PyTorch outside of the ESRI environment if you want to learn more. As far as the GIS realm, the GeoAI blog is a great resource, is kind of to figure out what ESRI employees are doing with the models and kind of cool GIS tasks. And of course, the ArcGIS API for Python sample notebooks is where you're going to get all these kind of sample products and like what you can do with your data. Now, because this is the ArcGIS API for Python, a lot of those are going to be through the Jupyter notebooks, which I also use myself. However, a lot of what you do in the Jupyter notebook can also be done within the geoprocessing tools within ArcGIS Pro. So what I'm going to do is I'm going to wrap up the slideshow. But first, I'll give you my contact information in case you want to email me with any questions.
Thank you. Hopefully there will be some questions.
And then I am going to show you the GitHub site. So this site is where you would grab the deep learning library installers for ArcGIS. Now, what you can do based off your version is you can download that installer. You install it on your machine. And what that will do is that will install the deep learning packages to your default Conda environment. So you don't have to create a separate Python environment, ArcGIS Pro, to install the necessary packages. The only caveat is that when you have a new version of Pro, you have to go and uninstall the deep learning installer, uninstall Pro, go through and delete one of the directories in the Python environment, reinstall Pro, and reinstall the deep learning libraries. But that is all kind of covered within the documentation on the GitHub site. All right, so the other thing I want to show you are the sample notebooks I mentioned on the ArcGIS API for Python. So we see there is a deep learning specialization here for notebooks. Now there's 2D computer vision, which I went over today. There's also 3D computer vision for utilizing point clouds. And then natural language processing. So address standardization is one of those useful kind of realms where natural language processing could help with as far as standardizing addresses. And then tabular data forecasting. Now, most of my work has been done with 2D computer vision. So if we go back in and take a look at, say, pixel classification, a lot of what you can do is like land cover classification, extracting building footprints, etc. But all these will go over kind of use cases that will kind of get you step by step the process of kind of going through the tools and kind of driving the data you're looking for. So I definitely recommend going through and kind of looking at the sample notebooks and seeing what they're doing. And you can replicate that in the ArcGIS Pro environment if you're not comfortable with using Jupyter notebooks.
Great.
And on the ArcGIS Living Atlas of the World, there are a number of deep learning packages available to you, which you can kind of plug and play with. For example, here's the building extraction footprint USA. And there's land cover classification. So in these cases, these models have been built out for extracting buildings. You don't have to train a model. All you have to do is implement the model. So you'd go in. So I have a specific area of interest. What I could do is I can run a geoprocessing task, detect objects using deep learning. My input raster, my current imagery, and detect objects. And from there, I can go and find that model definition through Living Atlas. And I will type in DLPK, and that will get you a list of all the deep learning packages you can get directly from the Living Atlas. So in this case, let's say use building footprint extraction. Okay. It's going to take a few seconds to load that model.
It's amazing how much easier it is now.
Mm-hmm. Now, of course, if I had this locally, it would work a little faster, but since it's pulling from Living Atlas, it's going to take a few seconds to learn the model definition and kind of set up the correct parameters as far as the arguments that you can use with that model definition.
Just a reminder for anybody that's here, if you have any questions or comments, go ahead and put them in the chat window, and we'll make sure they get addressed. All right, looks like it. Nope.
It is taking a little longer than usual, so we'll see if we can actually run through this demo. There we go. All right, so I'm just going to keep the defaults for now, but what I do want to set is my GPU processing and my extent. As I said before, I don't want to run the entire county. I'll just do my current display extent. Okay, and then you can either choose non-maximum suppression or not. So that means if you want to keep or remove duplicate objects. So that's really kind of up to you, your personal preference as far as what you want to do. But in this case, I'll go ahead and keep that unchecked so we don't create those. Right.
So with this, while this is running, do you think it's analyzing just textural images, or is it going down through, the entire spectral signature? Is it looking through all the different images in a multispectral image? Do
So
you know?
if it was trained on RGB imagery, I'm not 100% sure what they trained the USA building model on, but it's a combination of the spectral signature and then also like the neighbors, like so the pixel value and the neighboring pixel values to kind of
Okay.
generate the area.
So it's running a sweep filter through there and just,
Yep.
yep. Okay. Interesting.
Okay, so it's going to take a little time to spool up here. It should take about
Yeah.
2 minutes. There we go, we're running.
That
So in
is,
40 seconds, we have
wow.
buildings captured using the out-of-the-box model that we didn't have to train at all. Now, you do have some false positives, as you see here. Some of the road network has been generated as building, but for the most part, it is a pretty good job. But if we kind of dive down deeper, you see that these boundaries aren't really smooth. So the tool doesn't create rectangular boundaries; it is pixel-based. So it is going to kind of utilize the kind of resolution of that raster and kind of identify those pixels. So what you're going to need to do after running that tool is you're going to use the regularized building footprints. So once those buildings have been detected, you can go back in. If I can spell regularized building footprint. I will use my input features I just created. And so this is the method is where you're going to go and kind of dive deep into kind of how to best generate kind of those smooth boundaries for your buildings. But for the purpose of this specific demo, we'll just go ahead and keep it right angles, tolerance of 3, and precision of 0.25. That's good. Okay, so after running that regularization process, we can see we get those kind of smoother boundaries as opposed to what we had before. So it's not going to be perfect. However, it's a good start for kind of generalizing base map features for buildings. You can go back in and kind of do further work as far as kind of cleaning those up if necessary. But kind of for my purposes, as I was kind of explaining at the beginning, this is great for when I have the non-ad valorem season, where I need to identify where mobile homes have been kind of removed or placed on properties illegally, or we're trying to capture the appropriate fees. This is great where I have to go through and kind of, when we have a new set of imagery, scan the entire county manually. I can just run this process and kind of then once I get my output, just kind of run an intersect on our current building data and say, okay, what are we missing? What's different? So that's kind of the power of these tools.
So do you think it's precise enough to be able to utilize for change detection so that
Yes.
if in fact you can look for additions to homes and things of that sort?
Yep.
Interesting.
No, okay. So you, as you see here, you're going to get false positives,
Right.
but it is useful enough to kind of run through. You would have to kind of go through a process of determining what the best methodology would be. So in my case, what you'd essentially be able to do is you have this new set of building data you created from these tools using deep learning. And we have our current set of building data. What I could potentially do is create a centroid for each of those based off each polygon. If the centroid deviates like a certain amount,
Right.
I could say that there's probably some geometry change that exceeds such and such square feet. I might want to take a look at that.
Interesting. Interesting.
But yeah,
Wow.
this has been a big help as far as, my process each season of manually going through the new imagery that we might get from our vendor and taking a month or so and making sure everything looks good and, just running this, which, the small area took 2 minutes, but it'd probably take a day if I ran it countywide. And then kind of running through some modeling process and, selection processes through ArcGIS Pro, kind of getting output of, maybe a few hundred places where I actually need to like take a look and clean up our data.
Wow. Impressive.
Well, thank you.
Jason, do we have any other slides?
So we do. What I will also show you is, so you aren't limited to utilizing deep learning tools in ArcGIS Pro as kind of a GIS analyst or specialist. I would recommend taking a look, if you haven't already, the ability to help yourself with code with ChatGPT 3.5 or 4. Now, you do have cases where it might hallucinate results. And there is the time lag issue where it was last trained, I believe, in March of 2021, as far as the information that ChatGPT 4 has. However, you are able to feed it new information in your chats to kind of train it better on kind of like any new information or any new tools that might exist. So, for example, I've gone in and got help using arcade expressions for building pop-ups in my web applications by using ChatGPT 4. Additionally, I had a fellow employee had an issue where they wanted to go and review the XML for all our map services to kind of identify all the attribute information as far as the different layers in those map services and where they're coming from. And he really didn't have a good solution like out of the box. And he was good at Python, but didn't really, have the time to spend, a few days to kind of wrap his head around how to do that using Python. So using a few prompts within ChatGPT 4, as far as, I'm looking at XML files within a directory, how would I go through and kind of parse through that XML to kind of generate a CSV of all the kind of fields that I want in that XML with all those values. So by kind of prompting ChatGPT 4, I'm able to go through and retrieve code that gives me all the information I need from the individual XML files for those map services, get me the database IDs, database name, the connection string, the premise path, all that good stuff. And then searching through directories, we have that stored, and output a single CSV file. And so with that code, what you might run into is, because it's not really trained on your data, you might run into errors as far as like different naming conventions that you might run into with your XML file. What you can do is you can feed that error back into the model you're training and say, okay, I ran into this problem. It will learn on that problem and it will kind of update the code based off the problem that you ran into. So then it'll get you like a complete code that kind of debugs itself just with some prompting from you to kind of fit your data. And from there, I'm able to create an Excel spreadsheet that kind of outputs all that information as far as the service name, file path, all that stuff. So all that took me is about 15 minutes worth of prompting within ChatGPT 4. So it's definitely a very powerful thing as far as not only creating Python, but potentially helping you with like workflows. So I will often have an idea in my head of a problem I want to accomplish, but not quite sure the steps I want to take. It would be worth exploring if you asking, ChatGPT 3.5, which is free, or 4, which is a paid subscription monthly. I think it's like $20 a month. How you might do this in the realm of GIS or with ESRI software. And I would say it'll get you about 90 to 95% of the way there. You might get some hallucinated functions that don't actually exist, that it just look right. But you'll have to prompt it to say that, hey, this does not exist. How would I accomplish this without using this specific tool? So it is definitely something worth exploring if you have any interest. I definitely utilize it to help me with code. That would take me much longer had I not had the handicap here of ChatGPT.
Yeah,
So
we've been experimenting with it, and we're seeing similar results, maybe not quite 80-85%, but we're seeing similar, and it's enough to get us started with the core code, and then we wind up having to customize it for our own instances. But
absolutely, Yep.
I'm amazed, and it's not just Python. We've actually been able to do this with Arcade even to
Yep.
go and help us to get started. And it gives us that primary structure, and then we can build
Yes.
it out however we need. And I'm
Absolutely. Yeah,
I'm
I agree with you. That's the same findings. It gets you a great place to get started. You might need to tweak the code a bit, but it's much easier to start from ChatGPT than starting from scratch. If you're not an expert coder, can like sit down and just pump something out. So
yeah,
yeah.
I agree. I agree. Listen, this was amazing. This was amazing. Do you have anything else to go and share with us?
Not today, but if any of you have any questions, feel free once again to contact me. That's coxj@leoncountyfl.gov, and I'd be happy to kind of talk you through some of the projects I've had or any questions you might have over using these tools.
Great. So let me go and just get back to here. All right. And again, thank you, Jason. And hopefully, if you enjoyed this, you'll come back and let us know how you feel about this. And we can help you and continue with this as we go along. Stick around if you want, and we'll open up the webcams and open up the discussion, and we'll stick around and talk about it more. Thanks.